The Elizabeth Tower, known as Big Ben, is a masterpiece of Victorian engineering and a symbol of London. Its construction was a monumental task that took 16 years, requiring millions of bricks and immense dedication. To support this massive structure, engineers had to design a foundation that could withstand the test of time. In 1843, the first stone was laid, marking the official beginning of this historic project. Workers began by excavating deep into the London clay, digging a foundation pit 4 meters deep. This deep excavation was necessary to reach a stable layer capable of supporting the tower's weight. Beneath the clay, a natural layer of gravel provided additional stability for the massive foundation. Next, a solid concrete raft was poured, measuring 3.7 meters in thickness. This concrete raft was an advanced engineering decision, distributing the tower's weight evenly across the ground. The concrete had to be carefully cured for several weems to ensure it reached maximum strength. Once the foundation was ready, the construction of the brick walls could finally begin. To ensure the tower's durability, high-quality bricks were sourced and laid with extreme precision. The walls were constructed using a Flemish bond pattern, known for its superior structural strength. For the exterior, beautiful Anston limestone was transported all the way from Yorkshire. This limestone would clad the brick core, giving the tower its iconic Gothic appearance. Stone carvers meticulously crafted the intricate Gothic details that would adorn the tower's facade. Every single stone block was treated as a work of art, carved to perfection by hand. To tie the limestone cladding to the brick core, durable iron cramps were used. This composite wall design combined the strength of brick with the beauty of natural stone. As the tower rose, workers utilized an internal scaffolding system to lay bricks from the inside out. This innovative method meant that no external scaffolding was visible to the public during construction. A steam-powered hoist was installed in the center of the tower to lift heavy materials. This hoist lifted thousands of tons of bricks, stone, and mortar to the workers high above. The tower's design integrated a spiral staircase, a weight shaft, and a ventilation system. These elements rose together, forming a single, highly integrated machine of stone and iron. Finished. The spiral staircase consisted of 334 cantilevered stone steps. Each step was designed to support only itself and the air, anchored firmly into the outer wall. At 55 meters, the construction reached the level where the clock faces would be installed. This was the most complex engineering phase of the project, requiring absolute precision. The clock mechanism, designed by Edmund Beckett Denison, was to be the most accurate in the world. Denison invented a revolutionary gravity escapement that isolated the pendulum from external forces. This escapement ensured that wind and rain on the clock hands would not affect its timekeeping. The clock's pendulum was a massive assembly of steel and zinc, weighing 200 kilograms. It was engineered to beat precisely twice per second, maintaining perfect accuracy. The clock featured 3 separate gear trains, one for time, one for striking, and one for chiming. Each gear was manufactured to tolerances measured in thousandths of an inch. To power this massive mechanism, Heavy iron weights were suspended in the central shaft. These weights, totaling nearly 3 tons, would slowly fall through the tower over the course of a week. At the end of the week, the weights would be wound back up to the top by hand. Meanwhile, the construction of the 4 massive clock faces was underway. Each clock face frame was cast in iron, measuring 7 meters in diameter. To glaze the frames, 1,300 pieces of delicate opal glass were used. This glass was chosen because it would diffuse light evenly when illuminated from behind. The clock hands were crafted from copper and gunmetal to withstand the harsh London weather. The minute hands were 4.2 meters long, balanced perfectly to minimize friction. The hour hands were shorter but heavier, cast from solid gunmetal. With the clock faces ready, attention turned to the casting of the great bells. The first great bell was cast in 1856, weighing 16 tons. However, during testing on the ground, this first bell suffered a catastrophic crack. The crack silenced the bell, forcing engineers to melt it down and start over. The task of casting the second bell was given to the Whitechapel Bell Foundry. In 1858, the new bell was successfully cast, weighing 13.7 tons. This bell, named Big Ben, was decorated with intricate inscriptions around its rim. To transport this massive bell to the tower, a carriage drawn by 16 white horses was used. Thousands of Londoners lined the streets to welcome the voice of their new clock tower. Hoisting the 13-ton bell up the narrow central shaft was an extraordinary challenge. Because the bell was too wide for the internal shaft, it had to be turned sideways. It took 30 hours of continuous labor to hoist the bell to the belfry. Finally, the great bell reached its destination, 55 meters above the ground. In the belfry, the bell was secured to a massive cast-iron frame. Unlike traditional bells, Big Ben was designed to remain stationary, struck by a hammer. The hammer itself weighed 200 kilograms, designed to deliver a powerful blow. 4 smaller quarter bells were also installed to chime the Westminster quarters. These bells were tuned to perfect musical intervals, creating a harmonious chime. On May 31st, 1859, the clock mechanism was started for the first time. The steady tick of the clock filled the room, marking the beginning of its service. A few months later, in July, the great bell struck the hour for the very first time. The deep, resonant boom of Big Ben echoed across the city of London. However, just 2 months after its first strike, the second bell also cracked.
The crack was caused by a hammer that was far too heavy for the bronze.
To solve this, the bell was rotated 90 degrees so the hammer would strike a different spot. A small square was cut into the crack to prevent it from spreading further. A lighter hammer was installed, and the bell was returned to service with its unique tone. This unique, cracked tone became the beloved and recognizable voice of London, To complete the tower, a beautiful cast-iron spire was constructed at the very top. This spire rose another 35 meters, crowning the tower at 96 meters tall. The spire was decorated with hundreds of cast-iron tiles, each finished by hand. To add a touch of royal elegance, parts of the spire were gilded with gold leaf. The gilded details caught the sunlight, making the tower visible from miles away. The tower also featured the Ayrton light, a powerful lantern installed at the top. This light was designed to shine whenever Parliament was in session after dark. Inside the tower, a small prison room was built to hold unruly members of Parliament. Below the clock, archival rooms were designed to protect parliamentary records from fire. These rooms would safeguard centuries of history, protected by the tower's solid walls. With all components in place, the entire tower underwent a final, rigorous inspection. To fine-tune the clock's accuracy, pre-decimal pennies were placed on the pendulum. Adding or removing a single penny would adjust the clock's speed by 2/5 of a second per day. Finally, the scaffolding was removed, revealing the completed masterpiece to the world. Londoners gathered in awe to see the tower that would define their city for generations. Over the decades, the tower witnessed the rapid transformation of the city around it. Through wars and social revolutions, the clock never stopped, and the bell never fell silent. Even during the Blitz of World War II, despite nearby bomb damage, Big Ben kept striking. The bell's strike became a symbol of hope and defiance, broadcast to millions across occupied Europe. In the 21st century, the tower required its most extensive restoration to date. Completed in 2022, the restoration returned the tower to its original Victorian splendor. The original Prussian blue color, hidden under decades of black paint, was finally restored. Today, modern keepers wind the clock using the same mechanism and the same pennies. This connection to the past ensures that Victorian engineering continues to endure in our time. From a dusty construction site to a global icon, Big Ben remains a testament to human determination. It stands as a monument to the nameless craftsman, whose work will endure forever. Subscribe to Industrial Evolution for more videos exploring how the modern world was built.